What is wrong with you?
Always. Never.
So welcome, ladies and gentlemen. We were talking about solving right triangles and specifically looking at trigonometric inverses. And just as a quick review, a trig ratio, you give it an angle and it gives you a ratio. Okay? A trigonometric inverse, you give it the ratio and it gives back the angle. So it does the opposite sort of behavior. So if I was trying to solve cosine x equals the square root of 3 over 2, what I would do is cos inverse both sides. And cos inverse of cos x is just going to be x. And cosine inverse of root 3 over 2, let's see if my camera's, it's blurry. But nonetheless, I can still do a hand trick here. So cosine inverse of root 3 over 2 is asking the question, for what angle of cosine, or for what angle does cosine equal the square root of 3 over 2? So, bing, right there, right? So square root of 3 over 2 occurs for cosine at 30 degrees. So I can actually use the hand trick in reverse to figure that out. So x would equal 30 degrees. Now, they have two answers. Let's actually read the directions here. It says, solve each equation for 0 degrees is less than x is less than 360. So it turns out there is another quadrant that cosine is equal to the positive root 3 over 2. So at positive 30 degrees it happens, and also at negative 30 degrees, or 330 degrees, right? Because that still has a reference angle of 30 degrees, and cosine is positive in quadrant 4. So if this was a reference angle, right, I would just do 360 minus that to get 330. So that's how I get my two separate answers. Good stuff. And that's why I wanted to show you as well that you can use the hand trick in reverse for ones that at least have familiar values to them. Let's see if I can get some non-blurry images here. And 21 I hear is interesting. Name 4 angles whose sine equals 1/2. Blam. Bing, bing, bing. And here we go. So what does this look like? This is sine of whatever angle this is equals 1/2. So to solve that, I would sinverse both sides. Sine inverse, sine inverse. Sine inverse of 1/2 asks the question, for what angle is the ratio of the opposite to the hypotenuse equal to 1/2? Okay, that's what it's asking. For what angle is the ratio of the opposite to the hypotenuse equal to 1/2? Or for what angle is sine equal to 1/2, right? So when does that occur? Let's hand trick it to get our reference angle. Sine is 1/2 at 30 degrees. There's my thumb. Giant hand trick. Right? So 30 degree fingers down, one finger to the left, root 1 over 2 is 1/2. And so I get x is equal to 30 degrees. However, we know that sine can equal positive 1/2 in a couple other spots. Let's see. So at positive 30 degrees it works. It also works over here. In quadrant 2, sine is positive, right? So here is a reference angle of 30 degrees. Sine is positive in this quadrant, positive in this quadrant. So what is the measure of this angle? 180 minus 30 is 150. So there's another angle that it works at. And now if I wanted to find additional angles, would it work down here? Or down here?
Yes.
No. Sine would equal negative 1/2 in those quadrants, not positive 1/2. So I can, however, find some coterminal angles. What if I add 360 degrees to this one? So that green angle would be 390 degrees, right? Does that make sense? And then let's find a coterminal angle with 150. So 150. Let's see. So 150 plus 360 would be 460 plus 50, 510, right? 510 degrees. So those have to land in those quadrants specifically because of blah, blah, blah. I also technically could have had like negative 330 degrees or negative 210 degrees or technically infinitely many answers to this, but we narrowed it down to some of the ones that were closest to smaller values. Let's see, you guys wanted 25, was it? Arc sine and arc cos are other ways of just asking. Yeah, I saw him on the curriculum app earlier today during advisory.
Weird.
So let's see, paste. Here we go. I might just crank out all these in a row. So arc cosine, I unfortunately, due to lack of time, did not get to explain that to you. Arc cosine is the same as cosine inverse. It's just another way to say it. You know.
Mm-hmm.
So let's look at 23 specifically. All right. Now let's consider for 23 tan of tan inverse of 2/3. So make sure you guys are writing this down so that way.
Isn't it just like inverse?
Well, it's not multiplication, but think about this. 2/3 is a ratio, right? So I'm plugging in a ratio into tan inverse. What does tan inverse give when I plug in a ratio? It gives back an angle. And then I'm plugging that angle into tangent function, and it's going to give me back a ratio, because that's what tangent functions do.
So it's just
2/3.
It's just
So you
2/3.
think that because like tan inverse would cancel out with regular tan.
Yeah. We also could think about that as far as this, right? Those canceled out and just gave me x, right? That canceled out and just gave me x. So yeah, exactly. And think about it logically. It's saying, what is the ratio for which the angle has the ratio 2/3? Is kind of what that's asking. So it's 2/3, right? So it's just kind of like a little weird redundancy thing that cancels out. So in the case of 22, cosine of arc cosine is 4/5. Secant of cosine inverse. Oh, that one's an interesting one.
I have a question. How
Yes.
do we find, like, when you do it on the calculator, you get a decimal? And those are all, like, why are those all in fractions?
Because they were trying to do it without calculators. Let's look at 24 real quick, friends. So secant of cosine inverse of 2/5. So let's see. So cosine inverse of 2/5 is going to give us an angle. All right. Secant of that angle. All right. Cosine, remember, is ka, right? I think I just said ka, right? You could edit that out of the video. That's great. Krakatoa. Man, someone stole my awesome little clip over there. So anyways, secant is the ratio of what to what?
Hypotenuse to adjacent.
Right, Cho Shuk Hao. So cosine is giving me the angle for which cosine is 2/5. Secant of that angle would be 5/2. That's the way that that's working now. All right. No, dude, you can't bribe me, dude.
I was in kneecaps. I'm bringing you a slice.
I didn't suffer through kneecaps. I didn't earn it.
I did.
Oops. I should just eat pizza for the next 3 minutes of this video. Wow, pizza. So, anyways, now that I've been sufficiently bribed, thank you. Yeah, so this is 5/2. Let's take a look at another one. So 25 we actually did. So cosecant of arc sine of 1. Now, sine is the ratio of, well, the ratio doesn't quite work. Yeah, I didn't even go around and grade it yet. because this is tricky. We will, though. Write this down, though. It's good stuff. So sine and cosecant are inverses of, or reciprocals of one another, right? So we can take, if sine is the ratio of 1 over 1, the reciprocal of 1 over 1 is still 1 over 1, whichever way you write it. So cosecant and sine are the same ratio in both of these cases. Arcsine is going to give us the angle for which sine has the ratio of 1, which is 90 degrees, by the way. Cosecant of 90 degrees will also be 1.
What number is
Sine inverse and arcsine are equivalent concepts.
25.
So it's like in arc cosine.
Yep, right there. Which is the same as cosine inverse, right? Now, how about, did we do 27?
No, 27.
27 sounds awesome. Awesome sauce.
Awesome joy.
So let's see, 21. Let's see, sine inverse of 2/5 is going to give me an angle. Let's actually draw a picture of this, all right? Yeah. So sine, for my little triangle, blah, blah. Sine is 2/5, all right? So I'm getting the angle for which sine is 2/5. Sine is the ratio of... Sine is the ratio of... Opposite to hypotenuse. So the opposite is 2, the hypotenuse is 5. So cosine of this angle is going to be adjacent to hypotenuse, but I'd have to actually do some Pythag work to get that, right? So this is the square root of 21. Right, ladies, gentlemen, ladies? Square root of 21 is what I find there. So cosine of this angle, which I don't even know the angle yet, but that's fine. It's fine. Cosine of this angle would be root 21 over 5, which is what we found. I mean, arguably, you could actually figure out what that angle is by just doing sine inverse of 2/5. And I get 23.58 degrees, and then take cosine of that, but that's where, right, you would have gotten decimals, and the book had exact values. So that's what I just want to point out. Drawing a picture is actually usually very helpful, and just knowing Sokotoa Choshikau, right, you'll be halfway there in most of those cases.
Yeah, how do you spell Choshikau?
Cow. Which is... All right, these two letters are flip-flopped. That's a weird way to write an H. These two letters are flip-flopped, and then tangent, opposite over adjacent. Right, because tangent is the reciprocal of cotangent. Cosine is the reciprocal of secant. Blah, blah, blah. All sorts of good stuff. Whatever, I don't feel like undoing all that. That's fine. All of this box I'm ashamed of. How about one more question? Was there any good stuff on the back?
31. 29 or 31?
29.
20. Right, V and B sounds are similar in Spanish, am I not mistaken?
They're the same.
Are they? Oh, they are actually the same?
Mm-hmm.
There you go.
20.
Vente moco latte, moco, loco.
Crazy boomer.
Local latte.
I don't know. So, I guess I need the picture for this. What the heck? I'll just snapshot it.
Cheater.
Yep. I wonder if one of you guys would be able to figure out how to just like use a smartphone and like take pictures of problems and then put it into like the app Sketchbook Express, which is available on Android phones and such, and then like actually just like write your work over it in all the different colors, and then just email me the file when you're done. I'd be impressed.
My phone doesn't take Snapchat.
Yeah, that would also work. So let's see. It says if m is equal to 8, so that's little m. That's a side length. And p is equal to 14. There's a side length.
Okay.
It says find angle m. So I'm
Yeah.
looking for this angle. So what side is 8 from m's perspective? Opposite. Man, you've got it, dude. You've got it. And 14 is the hypotenuse, right?
Whatever.
Yep.
Stupid.
So what trig ratio compares those two?
Sine.
So
Sine, man, this guy's got it. So sine of my unknown angle, I was going to call it theta, but I guess I actually know what to call it. It's sine of m, will equal 8 over 14. So to solve this, what do I do? Sine inverse. Sinverse. Sinverse. So I get m is equal to the sine inverse of 8/14, which, 8/14 can reduce, but 34.85 degrees.
I got 1.
You got 1?
I got like 0.1.
0.1. Let's take a look at my calculator here, see if I can replicate your... You got 0.1?
I did it on our blue counts.
Unless it was in the wrong mode. Let me see what sine inverse is in radians. 0.6?
It's like 0.001.
Maybe 4.8.
I'm not sure how you got it. Yeah, I don't know.
The calculator.
If you can replicate it for me, I'll figure it out. So that's the idea is really draw pictures, know your ratios. I don't know. It's not terrible. Are you guys okay with hand trick reverse?
No.
Like if I ask you, here, let's do one of those right here on the video while I'm still recording. So if I wanted to figure out what is the cosine inverse of root 2 over 2, what finger would I put down?
Wait, what? Say that
It
again.
would always have to be over 2.
Your middle one.
Right. The middle one goes down, and that's true because of the square root of 2 over 2 works out. And what angle is cosine equal to root 2 over 2? 45 degrees. And then you could use that as a reference angle if it happened to be in a different quadrant. Or, for instance, when is sine equal to 1?
90.
30 degrees. So when you're in that...
Sine is equal to 1 at 90 degrees because the square root of 4 is 2, divided by 2 is 1. All right? Let's try one more. What is...
Are we going to be allowed to use the calculator? What?
Dude.
Sinverse is going to be on there, right?
Yeah, but it's all friendly angles.
No.
So, for instance, when is sine the square root of 3 over 2?
No.
Sine is the square root of the fingers to the left, so just keep trying until it works. And sine is the square root of 3 over 2 at which angle? 60 degrees. So sine inverse of root 3 over 2, 60 degrees.
Well...
Let's see if someone's brave. When is tangent equal to 1?
No. I can't do this.
90 degrees.
Tangent is the square root of the fingers to the left divided by the square root of the fingers to the right. So when would that ratio equal 1?
2. 45.
45, because root 2 over root 2 is 1. So all sorts of tricks and
Wait, tangent is...
gizmos
Right,
there.
yeah, I remember it all. It's all floating back to me.
Is it?
Mmm.
I think it's meatball.
Or Hamburg.
Yeah, something
Sliced. Yeah, I guess. So anyways, thanks for watching, everybody. Oh, actually, what, for this slice of pizza, actually, now that it's in first quadrant, theoretically, what is the ratio if I was to draw like a height right here? All right, and if this, say, the edge right here was 1, what would this height be right there? What would this angle be? If it's a pizza sliced into 8 slices.
30.
360 divided by 8.
Like,
180 divided by 4. 90
5.
divided by 2. 45 degrees. So, if this is 1, how could I find this awkward little height?
Like,
This is the opposite of that angle. That is the hypotenuse. So sine of 45 degrees equals x over 1. Sine of 45 degrees equals 1. What is sine of 45 degrees? What is sine of 45 degrees?
Square root of 3 over 2.
No, there's 2 fingers to the left.
1 over the square root of 2.
No. Or, well, okay.
Yeah.
You got me. Or root 2 over 2. All right? Excellent. 45 degrees is delicious.